this is practice set 78. I think you were supposed to do numbers 2 through 4. So here's number 2. Predict the sign of delta H for the condensation of water vapor, which is a gas, to liquid water. Explain your answer. So over here is the problem set solution from the answer key. And I'm going to give you my version of the answer and how I reason my way through this one. So let's write down what we know. We're taking H2O from a gas to a liquid, and I know that because it told me that up here. We know that gases are going to be hotter or warmer than something in the liquid phase. So we're going from a phase that is warmer to a phase that is cooler. In order to do that, instead of heating it up, heat is removed from the system. And whenever there's a loss of heat or a removal of heat, that means, therefore, delta H, this little symbol here, the three dots is therefore. It's kind of shorthand for therefore. Delta H is negative because there is a loss of heat from the system. And anytime there's a loss of something, you move into negative territory. You're subtracting. Question number 3, the diagram below represents a chemical reaction. What is the sign of delta H for this reaction? Meaning, is it positive or negative? And what you see here, you see that the products are lower, right? They have a lower energy than the reactants. That means that the reactants started up here at a higher energy. The product at the end of the reaction has a lower energy. So that means there has been a loss of energy, in this case heat. And anytime you have a loss of energy, that is a negative sign, right? If you have a loss of something, you're going to have a negative sign. So therefore, delta H is negative in this situation. Anytime those products are way down here, that means they have less energy than at the start of the reaction, and that means that there is a negative delta H, or a loss of energy. Alright, question 4. Explain why exothermic processes have negative delta H values, but endothermic processes have positive delta H values. Hint, remember that the change in a quantity is defined as the final value of the quantity minus the initial value. Over here is the textbook answer. I'm going to give you my version. Why does an exothermic process have a negative delta H? Well, we already talked about that, right? If something is exothermic, heat is leaving the system. Anytime something is leaving, that's a loss, and that's represented with a negative sign. The opposite here would be an endothermic process. Sorry, I meant to change the color. Would be an endothermic process, has a positive delta H value, and the opposite applies. In an endothermic process, heat is being absorbed by the system. When something is absorbed, it's being gained or added, right? And you represent that with a positive sign.